Welcome to another edition of Earth Science Skills School. Today we're reviewing the steps you must know to locate an earthquake epicenter. Oh goody. Remember that an earthquake epicenter is really just an imaginary point on the Earth's surface directly above the focus. Seismic waves are another name for earthquake waves. There are at least 4 types of seismic waves. The P waves, they're the fastest type, moving back and forth as they travel through solids and liquids. The S waves are slower, traveling side to side through solids only. In fact, seismologists infer the outer core of the Earth is liquid iron because the S waves can't penetrate it. Love and Rayleigh waves are surface waves responsible for most of the damage associated with earthquakes. Moving on to epicenter location, you'll need page 11 of your Earth Science reference tables. Go get them. To find an epicenter, you'll first need to examine the seismograms for 3 seismic stations. Here you'll see seismic stations A, B, and C. Use the recording stations data to find the P wave arrival time and S wave arrival time. This should be done by drawing a line from the initial arrival of each wave straight down to the clock. Here you can see the arrival time for San Francisco. It's 3:02:20 and 3:06:30. Next, we subtract the times to obtain the difference of 4 minutes and 10 seconds. Subtracting can be tricky because you have to borrow units of 60 seconds from the minutes column or 60 minutes from the hours column if you have to. Moving on to Station B at Denver, Colorado, we again find our arrival times and subtract to find a difference of 3 minutes and 20 seconds. Here we needed to practice borrowing 1 minute or 60 seconds of time. It's tricky, so don't forget to do this. Finally, for Missoula, Montana, we obtain a time difference of 2 minutes and 0 seconds. It's nice when the math works out. No borrowing. Now that we have 3 time differences for 3 locations, we can find each station's distance to the epicenter. Let's start with Station A. Its time difference is 4 minutes and 10 seconds, so we take some scrap paper and mark off a block of time on the left side of the chart, exactly equal to 4 minutes and 10 seconds. Remember, each increment on the y-axis is 20 seconds apart. Next, slide the paper, keeping it vertical between the P and the S wave curves until the tick marks make a perfect fit. When the tick marks line up, go straight down and read the epicenter distance. Remember that each line on the x-axis is worth 200 kilometers. Repeating this process for the other 2 seismic stations, we obtain all 3 distances to the epicenter that we'll need. Our next step is to triangulate the location of the epicenter. To do this, we'll open a drawing compass up, one at a time, to the 3 numbers we've measured. Use the scale on the map to open the compass to the right distance. With the compass centered on each station on your map, draw a circle of the correct distance until you have 3 circles completed. Your epicenter is located where the 3 circles intersect. Presto! You've located the earthquake. Congratulations. Thanks for watching. Another lesson from the Earth Science Skills School. Now go home and practice.